Hi, Roland is the name, networking is the game. Once again, welcome to my YouTube channel. We're learning the A to Z of network devices configuration, verification, and troubleshooting is guaranteed, as well as tips and tricks on how to authoritatively take full charge of your network devices. Now, recall in the previous session, the boss of my organization, PSL.com, asked me to configure the newly acquired routers such that a new staff, Hernandez, whose PC is connected to the last router, will successfully communicate with another staff, Julio, whose PC is connected to the first router. I use static route to accomplish this. However, this method gave me a little bit of stress, and it was kind of time consuming as my boss almost lost patience with me. Because we all know in business, time is money, and he was losing real cash. In today's tutorials, I'll show you how to accomplish the same goal using dynamic routing protocol, which is more efficient. Dynamic routing, which is more efficient and less stressful compared to static routing. Now, with dynamic routing, all you need to do on the routers is to configure a routing protocol of your choice, and voila, the routers will do the rest. To learn about routes by exchanging their routing tables, determine the best paths to send packets automatically, and even automatically adjust to reflect a change in the network topology. All these without human intervention. Isn't that fantastic? Specifically, we'll be configuring Routing Information Protocol today, RIP version 2. After today's session, you'll learn how to implement RIP version 2 on routers, how to verify the routing table with RIP running, and the difference between RIP version 1 and RIP version 2. Without further ado, let's begin. Okay, so as usual, I have selected some devices on the work pane. Now, in my previous classes, we had already given these IP addresses and then host names. In fact, we've done the basic configuration. But for the sake of those that might have not watched my videos or my previous videos, I'll just go over the basic configuration once again, giving IP addresses and host names. Okay? Now, recall that I named this device, this PC, we named it Julio. This was the PC that Julio was using. So let's still continue with that trend. So this is Julio. Now this PC belongs to Jones, the London guy that's connected to the London router. Okay, well, this PC, this is the new staff, Hernandez, the Spanish guy. Okay, so Hernandez. Okay, now this router was the is Rome. This is the Rome router. Okay, this is the London router. Okay, and then is the Madrid router. Okay, now as usual, we'll first of all connect this this cable, the crossover cable to the fast Ethernet port of the routers. Okay, and I told you the kind of cable to use when you're connecting like devices in my previous class. Okay, so we'll connect this. Good. Now, because I don't want to throw around PCs on my work pins, I'll basically use the same PC to log into the router. So what do I mean? I'll have to connect the console cable to the same PC that is connected to my router via the crossover cable. Okay, just because I don't want to use too much PCs on my work screen. Okay, so I'll do this for all the devices on my pin. Good. Now I have to connect my serial cable as usual. Oh, I don't have a serial port yet. So as usual, I'll log into this router. I'll go into this router and insert modules, serial modules, and just like we did in previous class, we switch off the router first and then select this module and power it back on. We'll do the same for this router. However, this router will need 2 of those modules, so we'll connect 2 of them. Okay, power the router back on. Okay, then the final router, just one of that module. Good. Now I can successfully and confidently connect my serial cable. Okay, good. Now I'll log into the router to configure. Okay, so I'll log in through the terminal as usual and then answer no to this question and begin my configuration. So first and foremost, remember, we'll go and give it a host name. Okay, what's the host name here? Room. Okay, then we'll go straight up to the interface serial 0/3/0, give it an IP address. So we are giving it 192.168.10.1, 255.255.255.252. Clock rate, remember we have the clock sign here, 64,000. No shutdown. Exit. But now we'll now go to the interface fast Ethernet 0/0. Let's give it an IP address of 172.16.1.1, 255.255.255.240. No shutdown. Exit. Now let me save my configuration. I'll save my configuration and go to the other router. Okay, before implementing my RIP, I just have to save and let me finish the basic configuration first. Okay, and I'll log into this router via the host as usual. Answer no to this question. Proceed to the global configuration mode. Give it a host name. Host name London. Okay, then interface serial 0/3/0, the interface connected to the room router. We'll give it an IP address from the same subnet, which is 192.168.10.2, 255.255.255.252. No shutdown. Exit. Now the interface connected to the Madrid router, that should be interface serial 0/2/0. IP address, let's give it 192.168.20.1, 255.255.255.252. Now I believe we have to do clock rate here. Enter the clock rate command. No shutdown. Exit. We proceed to the fast interface, fast Ethernet interface, fast Ethernet 0/0. IP address, let's give this 172.16.2.1, 255.255.255.240. No shutdown. Exit. Okay, once again I'll save and proceed to the third router. Okay, on the third router, okay, we'll name it what? I think this was named Madrid. Host name Madrid. Okay, interface serial 0/3/0. IP address 192.168.20.2, 255.255.255.252. No shutdown. Exit. Interface fast Ethernet 0/0. IP address 172.16.3.1, 255.255.255.240. No shutdown. Exit. Once again we'll save. Okay, good. Now after I've done that, I need to enable my routing protocol. And just like I said initially, the routing protocol we are talking about today will be RIP. Now RIP is an open standard routing protocol, so it can work on, it's not proprietary to any device, and it can, any model or any manufacturer, it can work on all devices, Cisco devices and every other device. Okay, so I'll log in. This is how you configure RIP. From the global configuration mode, rather than using static routes that we saw last class, which was stressful like I said, we can use RIP to ensure connectivity. This is our aim, from this first device to the last device. Okay, so that this device will be able, Julio should be able to communicate with Hernandez in Madrid. So the RIP is the routing protocol we use to make this happen. When we enable RIP, the RIP protocol running on this router will exchange routing update packets with its neighbors, and the routing update packets will contain information about all the routes that each and every one of these neighbors are aware of. Okay, and so through that they'll be able to build their routing table and then forward packets. That is the aim. And so after this configuration, we'll also verify the routing table. Okay, so I'll log into this router. All you need to do from the global configuration mode, you enter the command router rip. Now, the difference in configuration between version 1 and version 2 is that if I'm configuring version 1, I don't need to enter this next command, which is version 2. I have to specify the version only when I'm configuring RIP version 2. Okay, if I'm configuring RIP version 1, I'll not type version 1. If you leave it like that, the router by default knows that you are configuring version 1. Then you proceed by typing network. Now, when you type network, we are trying to advertise directly connected networks to the router. Recall that when we discussed static routes in the previous class, we told the routers about routes that are not directly connected to the router. For example, on this router, we told the router about this network and this network, but not this and this, because they are directly connected to this roam router. Likewise, on this router, we told it about this network and this remote networks. We didn't tell it about this and this because they are directly connected to the London router. But in routing protocol configuration, it's the opposite. Okay, so I'll be telling this router about this network and this network directly connected. I'll tell this router about this network and this network, this router about this and this. And so these routers will now forward information about the networks that are directly connected to them to their neighbors, such that their neighbors will be able to build their routing table and learn about routes. Okay, so that's the idea. That idea it's applicable to almost all routing protocols. So network. So this network, remember, it's 192.168.10.0, while this is 172.16.1.0. That's exactly what I want to type. First network, 192.168.10.0. Enter. I'll repeat the same thing, but in this case for the other directly connected network, 172.16.1.0. Okay, now that should be all, but there's a very important command that you need to enter when you are configuring classful routing protocols. Okay, I'll discuss that in my other class. Okay, classful routing protocols, which RIP is one of them, EIGRP is another one. It's recommended to enter no auto summary. Why? I'll just brief you. Now, classful routing protocols summarize networks about their classful boundary. Okay, and so if, like for example, what I mean summarizing about their classful boundary is that they automatically summarize. For example, you can see this network 172.16.1.0. it's actually a class C, class B network subnetted into C, so to say. But if this router wants to recognize this network, it will see it across the classful boundary of 172.16, okay, .0.0. So it sees that across the classful boundary, and this might not be very helpful, because if this router is connected to this network and is connected to another network of 172.16.2.0, it means it will see both networks across the classful boundary of 172.16.0.0, and so it will cause confusion, leading to what we call suboptimal routing. Okay, I don't want to go into details now, but that is just the idea. So it's advisable, and that occurs when you have a kind of, a network scenario where you have the same networks separated by two networks from the same subnet separated by network from a different subnet. It causes suboptimal routing. So entering no auto summary, you are disabling the automatic summarization effect. And so this network will be sent the way it is. Good. Preventing what? Suboptimal routing. Good. Now I'm done with that router. So I'll go and save. Hope that's clear. Okay. I'll go to this router and do something similar. That's a wonderful tip. Not everybody will give you that tip. It's priceless. Okay. So router RIP version 2. In this case, we'll have network 192.168.10.0, network 192.168.20.0, no auto summary. We exit. Okay. And save. We are done with our router. I'll log into this router as well. Okay. Router RIP version 2, network 192.168.20.0. Okay. Network 172.168.3.0. No auto summary. Okay. Now I forgot one net to advertise a network on the second router. You should have reminded me that. Okay. So I'll go to this router, this network. I've not advertised the 172 network. Okay. So I'll go to this router, router RIP, the network 172, because any network you fail to advertise, there will be no communication to that network. 16.2.0. Okay. So I'll save once again. Good. I'm done with my configurations. Okay. Now the difference between RIP, now RIP version 2, for example, can work as a classless routing protocol. Okay. What that means, it can work in a kind of variable length subnet mask topology. You can see that this particular, not classless routing protocol, sorry to say, but it works in a VLSM topology where you have different slash notation. You can see I'm using /28 here, /20, /30 here, /30 here, and /28 here. Okay. In fact, let me put this so that we've seen what we are doing. Okay. So here I had 192.168.10.0 network /30. Okay. Here I had 192.168.20.0 network /30. Okay. Here I had 172.16.1.0/28. Okay. Here I had 172.16.2.0/28. Here I had 172.16.3.0/28. Okay. Good. So you can see that I had /28/30 here. So on this network topology, I'm working with variable length subnet mask. And so on such topology, RIP version 1 will never work. So had it been I just configured RIP version 1 on this topology, I will not be able to ping from here to here. Let's try pinging first and see. Okay, so I have to start by giving this an IP address, obviously, and default gateway. Okay, so that's the essence of RIP configuration. And another difference between RIP version 1 and RIP version 2 is that RIP version 2 supports, in as much as it supports VLSM, it also supports authentication. So I can configure authentication on these routers, probably in my some other classes, whereby these routers, before they can exchange routing updates, they need to send some kind of passwords. Okay, that's very important. Okay, then you should be you should be able to distinguish between RIP version 1 and RIP version 2, really. Okay, so now we are done with our configuration. We'll try pinging from here to here. Okay, if we can ping successfully, it means our topology is working. Okay, now before we proceed, let's take some time, pause for a while. Okay, click on the subscribe button so you get notified on my subsequent videos. Okay, good. So good. So basically, it's very important to understand that this RIP version 2, it's a very wonderful routing protocol, and we all know that it has a maximum hop count of 15. What that means is that there's no way you can configure RIP on a network that has above 15 routers, because the 16th router will potentially not get updates and so will be out of communication or connection. Okay, so some of these little things you need to understand about using routing protocols so that you'll be able to choose the best routing protocol for your network scenario. Okay, so again, it's a wonderful protocol, but it's a kind of a little bit, it consumes bandwidth because it sends its updates. Good, this is a third feature of RIP version 2 now. Unlike RIP version 1 that sends its update as broadcast, RIP version 2 sends its update as multicast. What that means is that if you configure RIP version 2, update can be sent from this router to this router using a multicast address of 224.0.0.0.0.9. Okay, unlike RIP version 1 that will send its update as broadcasts using up the bandwidth. Okay, so these are some little things you need to know about RIP routing protocol and how to distinguish between RIP version 2 and RIP version 1. In summary, the differences, the major differences between RIP version 2 and RIP version 1 is that RIP version 2, first and foremost, can work supports VLSM topology, but version 1 does not. Secondly, RIP version 2 sends its update as multicast, while RIP version 1 sends its update as broadcast. Then RIP version 2 supports authentication, while RIP version 1 does not. Okay? In next class, we'll talk about EIGRP, another routing protocol. However, in this case, with EIGRP, we'll be able to configure it as well. Okay? So, now, with this configuration, we should be able to ping from this router to this router. Okay? I mean, from this PC to this PC after giving it an IP address. We've not set the IP address yet. Okay? Good. Yeah, so this is where we'll call it a day. Okay, hope you had a wonderful time as you embark on this superb journey of unlimited treasures. If so, continue to subscribe if you've not, and drop your comments below. In addition, for further intensive training and consultation, chat me up via my email provided below. Thanks, and once again, arrivederci.